Okay, so let's take a look at the solutions to these conversions problems from moles to grams to particles. How many moles are there in 24 grams of iron 3 fluoride? Always start off with writing what we are given. We are given 24.0 grams of iron 3 fluoride. I'm going to leave myself some space. I'm going to come over here and I'm going to say, well, how many moles of iron 3 fluoride would that be? Okay, well, we know there has to be some ratio between grams and something else. And because of what Avogadro did with the periodic table, we know that we can go to these numbers on the periodic table, and that's the number of grams in a mole. So we're going to go to iron 3 fluoride on the periodic table and figure out how many grams there are in 1 mole of iron 3 fluoride. So I have to add up 3 fluorines and 1 iron. And I would see that, fluorines are 19. So I'm going to have to take 19 times 3. So fluorine is going to be 57, but then iron is another 56 by itself. So the total grams per mole for iron 3 fluoride is going to be 113. So it's 113 grams in 1 mole. That will cancel out grams for me. Well, I wanted to find moles. I got grams, moles. Well, that's it. I'm done. I have the unit that I want to solve for. So I would take 24.0 divided by 113. That's going to give me 0.21. And that's it. Okay. Now, this one we want to know how many moles are there in this many grams of sodium sulfate. So once again, write down what you were given. 458 grams Na2SO4. We'll come over here and say, well, how many moles of Na2SO4 would that be? Grams of Na2SO4 to 1 mole of Na2SO4. Now remember, this number comes from the periodic table. And I'm going to go to the periodic table. I'm going to see that sodium is 23. So there's 2 sodiums. There. 2 times 23 for each sodium. Okay, that's 46. But then there is a sulfur, which is 32. But then there's 4 oxygens, which is 64 total. So the grams per mole for sodium sulfate is 142. That'll cancel. So now I've got 458 divided by 142. If each mole is 142, but I have 458 grams, I've got more than 1 mole's worth. So to figure out how much, I go 458 divided by 142. So 458 divided by 142 equals, I've got 3.2 moles. 3.2 moles of sodium sulfate. Okay. Those were kind of more like review questions. We had already done those, and y'all did pretty well at those when we had the, assessment on that. So now let's throw in there what we did yesterday. That's where we start talking about the number of atoms, going from grams and atoms or particles. Still works the same way. I'm going to come over here and write down what I'm given. 2.30 times 10 to the 24th atoms of silver. And I want to know how many grams of silver would that many atoms be? Okay, so is there something we know about a number of atoms of silver? Well, we do know how many atoms are in 1 mole of silver. That's that Avogadro's number. There are that many atoms in 1 mole of anything. So there goes atoms of silver. Now I've got moles of silver, but I want to know grams. Well, I know that ratio I can get from the periodic table. 1 mole of silver, when I come to the periodic table, is 108. We'll just round these to whole numbers to be nice and easy today. All right. So now we got to do some math with this kind of funky big number here, this Avogadro's number. All right. Slide this up a little bit. So hopefully we can get all this on one. Let's talk about how we do this mathematically. Gonna block that glare. All right, we'll try. 6.022. I'm going to hit the double E button here on my calculator. That one right there. That's the one that will make the times 10. Now, it's gold, so I got to do the second double E. And that's what it'll look like. That means when you see that little E on it, that means times 10. Well, times 10 to the what power? 23rd. Okay. But I need to multiply that by 108 times 108. So that's what I get across the top. Oh, I did that wrong. I put in the wrong number there. 6. I gotta take 2.3 times 10 to the 24th times 108. That. Now I can divide that by 6.022 exponent 23rd. I have about 412 grams. So this is one of the mistakes you're going to make, is putting those numbers in your calculator incorrectly. If you have a different calculator, it's not a graphing calculator, I can work with you and show you how to do the exponents correctly. Okay, how many grams are there in 7.4 moles of silver nitrate? All right, we know that 1 mole of silver nitrate is a certain number of grams from the periodic table. So I have to add up a silver, which we already found out was 108. I'm going to do that off the screen here. 108 for silver, plus a nitrogen, which is 14, plus 3 oxygens, which is 48. This gives me 170 grams of silver nitrate per mole. Okay, now I've got grams. Oh man, that was it. That's all I have to do. I'm done here. All right, no funky Avogadro's number here. I can just take 7.4 times 170 will give me 1258 grams. All right. How many grams are there in this number of molecules of H2SO4? Okay, well, notice I didn't call this atoms of H2SO4 because it's not an individual element anymore. Now it's a compound. So we talk about molecules of a compound. I want to know how many grams. Well, I know that there are 6.022 times 10 to the 23rd molecules of H2SO4 in 1 mole of H2SO4. But I want to know grams, so I've got to go 1 mole is how many grams. And for that, I've got to go to the periodic table. I've got to take 4 oxygens, which is 64, plus a sulfur, which is 32. Once again, I'm looking these up on the periodic table, plus 2 for hydrogen equals 98. Okay, now this is just a math problem. And let's talk about how to do the math. I'm going to multiply across the top. Go 7.0 exponent 23 times 98. All right, so that's what I get on the top. Now I'm going to divide that by Avogadro's number. And that's what I get. I would have 122 grams of H2SO4. Okay. How many molecules are there in 122 grams of nitrogen dioxide? Okay. I know how many grams there are in a mole if I go to the periodic table. I know that one nitrogen is 14, each oxygen is 16, so that would be 32 plus 14, 46 grams. Now that only gives me moles. I want to find out how many little pieces there are, how many molecules. So I have to use the relationship that 1 mole of anything is that many pieces of that thing. Okay, now this is a math problem again. Multiply across the top. 122 times 6.022 times 10 to the 23rd. I always like to hit enter instead of doing it all in one. There's my number across the top. Now I'm going to hit divided by 46. I get 1.597. Let's make that 1.6 times 10 to the 24th molecules. All right, so let's look at how many grams there are in that many molecules of H2. I want to always write down what I'm given. 9.40 times 10 to the 25th this time. And I want to know how many grams of H2. Well, I know there are this many H2s in a mole of H2. And I know that 1 mole of H2 is about 2 grams of H2 from the periodic table. So now, take that number there, 9.4 exponent 25th times 2 across the top, then divide by about 312 grams. There we go. 237 grams of ClCO carbon tetrachloride is how many molecules? Well, I know how many grams of ClCO4 there are in 1 mole of CCO4 carbon tetrachloride. I have to do some quick math here. I know that each chlorine is 35.45 from the periodic table, and times that by 4 plus 12 for that carbon gives me 153.8. Let's go 154. Close enough. All right, that gives me moles, but I need to know that in 1 mole of carbon tetrachloride, there are that many molecules. So now we're doing our math. I want to go 237 times Avogadro's number, then divided by 154, 9.27 times 10 to the 23rd. Okay. 2.3 grams of ammonia. How many molecules? Starting to go a little bit faster just because I think we're probably starting to get the hang of this. There's 17 grams in 1 mole. And in 1 mole, there are 6.022 times 10 to the 23rd molecules. So I'll go ahead and do my math here. Always trying to show you how I'm getting the math so that you can follow along on your calculator. All right, remember the double E button times 10 to the 23rd. Okay. Divided by the denominator of 17, I'm going to get 8.15 times 10 to the 22nd molecules. Turn that so you can see that exactly how I did the math. How many grams are there in this many molecules? 3.3 times 10 to the 23rd molecules of N2I6. How many grams? Oh, went too far. Okay, we know there's 6.022 times 10 to the 23rd molecules of anything in a mole. Allows me to convert that there. We also know in 1 mole how many grams there are because I can get that from the periodic table. So that's the grams per mole. Big compound because it's got 6 pretty big iodine atoms in there. So let's do the math. 3.3 exponent 23rd times 790. That's what's on the top. And we divide by Avogadro's number on the bottom. And we will get 433 grams. Now notice this one here, this one's a little bit simpler because we're given molecules and we just need to go to moles. We're not going all the way to grams this time. So make sure that you follow this process, that you write down what you're given and then what you're trying to find. And that'll kind of tell you where to stop with the problem. So we got times 10 to the 23rd molecules in 1 mole. I don't need to go to the periodic table for this one because I'm not doing anything with grams. I can just do my math. Got 3.3 times 10 to the negative 5th moles. That's a pretty small number. And if you think about it, there are 6.022 times 10 to the 23rd in a mole. And I've only got a times 10 to the 19th. I've got a lot less than a mole's worth of stuff here. So it ended up being a pretty small number. It's going to be 0.1234 And that makes sense because that number is a lot less than that. This would be like saying, how many dozen do you have if you have 2 eggs? Well, you don't even have, you have a lot less than, it's point something of a dozen. It's the same concept here. All right, so this one I went ahead and set up, trying to speed this up a little bit. We're given the molecules of boron trichloride. We know there's that many molecules of boron trichloride in a mole, and that 1 mole is that many grams worth. Once you do the math correctly, that's the answer you should get. All right, so once again, I went ahead and set this one up, and you'll see, oh man, I looked like I was trying to do another step in there. And then I caught myself and realized, oh, wait a minute. Here I am at grams, and that's what I was being asked to solve for. So this didn't have that extra step of having to go to particles. And finally, here's the setup for our last one, where we have grams of water, and there's 18 grams in 1 mole. And in every 1 mole, there's that many molecules. That would tell us how many molecules there are in water. If you have any problems with how any of these problems were set up or how they were solved, you'll have a chance to have a little question and answer session with me, and we'll get everything cleared up before we move on to an assessment.